Welcome back everyone. So in the last video we solved cache with time limit, and in this video we are going to solve debounce. So let's get started. So we are given a function fn and a time in milliseconds t. So we are given a function and time limit t in milliseconds. We have to return a debounce version of that function. A debounce function is a function whose execution is delayed by t milliseconds and whose execution is cancelled if it is called again within that window of time. The debounce version function should also receive the passed parameter. For example, let's say t is 50 millisecond and the function was called at 30 millisecond, 60 millisecond and 100 millisecond. Now, when you call at 30 millisecond and then at 60 millisecond, the gap is 30 millisecond. The first two function call would be cancelled. So 30 millisecond, and before even 50 millisecond would have elapsed, we have made another call at 60 millisecond. And then before even this function is invoked, we made another call at 100 millisecond. That is, the gap is 40 millisecond. So these two function calls will be debounced. So first two function call would be cancelled and the third function call would be executed at 150 millisecond. So if instead t is 35 millisecond, the first call would be cancelled, the second call would be executed at 95 millisecond and third call would be executed at 135 millisecond. So let's understand this using an example. So the requirement is that, let's say t is 50 millisecond, and if before this millisecond, 50 millisecond, someone has called another function. So in this duration, that is 0 to 50 millisecond, if 100 calls are made, then those 99 calls will be rejected. So the first call is made at 50 millisecond, then the next call is at 75 millisecond. So the first call will be rejected. So the only thing is that if the gap between two calls are t milliseconds, then separate calls will be made. But if the gap between the last call and the current call is not 50 millisecond, then you have to cancel the last call. Okay. So you see the first call is 50 millisecond, then is 75. So the difference is 25 millisecond, which means we have to cancel this old callback. Okay. Let's see. Set timeout 50, set timeout this. So what it will print is, it will print 2. So output is t is 125 millisecond and inputs are 2. So you see the first call which has input of 1 is rejected and the second one is accepted. Let's see. The time window is 20 millisecond and let's say there are 50 calls in that window, then we have to reject all the 49s and execute the last one. Okay, so the only thing you have to keep in mind is that the difference between the two function call should be 20 milliseconds. So that's the debounce. We debounce all the calls that are made with that window less than 20 millisecond. So first call is made at 50 and then at 100 millisecond. So see, there is a difference of 50 milliseconds, which means both the calls will be executed. So output, the first call will be at 70 and with an input of 1 and the second at 120 millisecond with an input of 2. So these two, both the calls will be executed. So none of the call will be debounced. Okay. Similarly for third example, now let's see how are we going to solve this. So we will call this function. So there is a timer, let timer, which is null initially. So timer is set timeout, and what we'll do is we'll call fn with args after t seconds, and if this function is called again, we'll clear timeout with timer. That's it. Okay, so all the test case has been passed. Now let me first explain what are we doing. Now you have a timer variable that is enclosed for this function. Now whenever this function is called, we'll clear if there is any timer. If there is no timer, doesn't matter. Okay. Now we will set timeout. We will call this function after t milliseconds. After t milliseconds, we'll call this and we'll store this in a timer. Now there will be two cases. Let's say this function is called again and this timeout is still running, which means the t millisecond is not yet elapsed. So this function is not yet executed. In that case, clear timeout will stop this timeout. Okay, that's what we want. Okay, so for example, the timeout is 100 milliseconds, 100 millisecond, and you made 1000 call to this function. For every call, since the timer is still running, it will clear the timeout. It will set the timeout again for 100 milliseconds. If you call again, you will clear the timeout and you set the timeout for 100 millisecond again. This keeps on doing until the last call. So until the last call, you clear the timeout, you set the 100 millisecond again. So this keeps on. For example, here you see debounce log 100 millisecond. You call the hello. So you set the timeout for 100 millisecond. You call hello again, which means you clear the timeout, you set for 100 millisecond again. You called hello again, which means you clear the timeout, all the timeout, and then set that timeout again. So these two are cancelled. Okay, we have done the clear timeout, and this last one will be executed by this timeout. Now the second case is you are calling this function, but the timeout has already been executed. So in that case, clear timeout timer. Since the timeout is already executed, it doesn't matter the timer is we are cancelling or not because the function is already executed. So clear timeout will do nothing. Timer is already expired, right? So we will set a new timer. Okay, so that's what we are doing. So for example, let's say this log is called at after this 100 milliseconds. So initially it is called, then this second will be called, for example, let's say 150 milliseconds. So when this is called, we'll do clear timeout, but this function is already executed. So it doesn't matter we are clearing timeout or not. Okay. So this is redundant in that case. Then we'll set for 100 millisecond again. Now let's say we are calling this at 250 milliseconds. So this is already executed, so it doesn't matter clear timeout or not. So this function will handle both the cases. So clear timeout will clear the timeout if it is running, and if it is not running, it will do nothing. Okay. So now let me submit this. Okay, so our solution got accepted.